without compromise. Educating you without compromise.
Okay, now we are through with the revision on velocity time graph. Now let's go straight to the equation of uniformly accelerated motion. We have 4 equations to determine the motion of an object that moves in a straight line. First, we have v equals to u plus at. Then the second one is s, ut plus half at squared. The third one is v squared u squared plus 2as, while the fourth one is s equals to average velocity multiplied by time. So these are the 4 equations that can be used to determine the motion of a linear a body that moves linearly or in a straight line. So we're going to take an example to determine either of the first equation or the second equation. Remember that v simply means final velocity, while u is initial velocity, a is acceleration, t is time, then s is called distance, horizontal distance. So let's take example. Example. A body accelerates in 2 seconds with a velocity of 4 meters per second. Calculate the final velocity attained by the body. Now, in physics, solving any question, the first thing is to bring out the parameters. What do I mean by parameters? The information stated or given in the question. First, they said the body accelerates in 2 seconds. So t is 2 seconds with a velocity of 4. Now, they said it accelerates in 2 seconds with a velocity of 4. That 4 means initial velocity. But if it is stated in the question that a body accelerates from rest, it simply means initial velocity is 0. So the next parameter we're asked to determine v, which is u now. They said with a velocity, that's the velocity at which the body accelerates. So it's termed u, which is 4 meters per second. And we're asked to determine v. V is unknown. Now, the acceleration of the body is not stated. So we need to state the acceleration of the body. So let's assume the acceleration is 2 meters per second squared, so that we can finally have a complete relation to determine the unknown parameter here. So using these 4 letters, a, v, u, and t, we can go straight to the first equation of motion, which v equals to u plus at. So we are looking for v. What is u? U is 4 plus a is 2 times, what's the time? Which is 2 seconds. So 4 plus 2 times 2 becomes 4. So we have 8. So the final velocity attained by the body is 8 meters per second. So this is an example on how to solve the first equation of motion. In our subsequent classes, we'll go straight to the other equations. The next we're considering is the motion of a body under gravity. Motion of a body under gravity. Now, a body under gravity simply means is either the body is going upward or is coming downward. That's just the difference. Now, for example, if an object is going upward, the acceleration is equal to minus g. Why is it minus g? Because it's against gravity. For example, if you are walking on a staircase, by the time you go up the staircase, you notice that it's difficult to move upward than coming down from the building. So that is why we are having a negative answer. So you are trying to go against the force of gravity. But a body coming down, acceleration is plus g. That is the difference. So when a body falls from a certain height and is falling towards gravity, acceleration is equal to plus g. G means acceleration due to gravity. And at this maximum height, the final velocity is 0. So when an object is thrown vertically upward, at maximum height, the final velocity is given as what? At 0. But when a body falls from a certain height, initially the body is at rest. This is called initial velocity, which becomes what? 0. Now quickly, what are the relations to determine the motion of a body under gravity? We have the first, V equals to U plus or minus GT. Why is it plus or minus GT? It depends on the question at hand. So if it involves the object moving upward, we're going to use V equals to U minus GT. It's moving upward or is thrown vertically upward. Why the second equation, we use H because we're dealing with height. So we have UT plus or minus half GT squared. You know, we're no longer using A here now. We're using G because it involves motion under what? Gravity. While the third one is V squared, U squared plus or minus 2GH. So these are the three equations that can be used to determine the motion of an object which moves either vertically upward or vertically downward. Quickly, let's take an example on this. An object is thrown upward with a velocity of 2 meters per second in 4 seconds. Calculate the final velocity. Now, normally we give G here. G equals to 10 meters per second squared. Sometimes G, which is acceleration due to gravity, can be given in 9.8 meters per second squared. So, first of all, they said an object is thrown upward with a velocity of 2 meters. That means the velocity at which the object ascends that height is U, which is 2 meters per second. And the time in getting to that certain height is 4 seconds. We also calculate the final velocity, which is V, and they gave us G equals to 10 meters per second squared. So, from the three equations of motion under gravity, we can use V equals to U minus GT. Why are we using minus? Because they said an object is thrown upward. So the object is moving against gravity. That's why this negative sign is written. So the value we have for U is 2 minus G is 10, while the time is 4. So times 4. So we have 2 minus 40. So we have minus 38. So you can see that the motion of this object is against gravity because final velocity can be in terms of positive or negative value depending on the motion of the what? Of the object. So we can also have it in a positive form if the parameters given can give us that positive value. So with this, I hope you understand the topic, motion under gravity. Thank you and God bless you. See you in our next class.
Educating you without compromise.